So we're now going to talk about the filter class hierarchy. And this particular part of the discussion is not quite as much concerned with concurrency and asynchronous computation as it is showing off a really cool example of applying the decorator pattern in the context of concurrency and asynchrony. So let's take a look at this. First, here's the filter hierarchy classes. We've got filter, we've got grayscale filter, null filter, filter decorator, and output filter decorator. At a high level, these classes in this class hierarchy provides the means to apply a series of filters to process and store each downloaded image. And it does it concurrently because we're using it in the context of the image task gang and the executor completion service. But we're really focusing here on the decorator pattern. And you can see here how we show it. These are all part of the decorator pattern, and we show specific examples of what they are. So we have the filter is a component. The null filter and grayscale filter are concrete components. And then we have the filter decorator and output filter decorator, which is either a decorator and or a concrete decorator. Actually, I should say that it's a decorator and a concrete decorator, respectively. So let's kind of break this down because there's a lot of pieces going on here. First, remember that the decorator pattern allows the behavior to be added to an individual object transparently without affecting the behavior of other objects from the same class. So first, let's take a look at the filter, which is the component in the decorator pattern. And you can see it's got an abstract method called apply filter, which of course it does not implement. It just makes that as something that's an obligation for a subclass to implement. And you can see that it plays the role of the abstract class in the template method pattern, as well as the component class in the decorator pattern. And this kind of design is what's often referred to in the literature, particularly the pattern-oriented software architecture book series, as a high pattern density design. And I tend to like high pattern density designs because it typically shows the person who's doing them has thought about their design carefully and figured out the different roles. Some people don't like them, but I tend to like them. So you'll see me do that as much as I can. So remember, the template method pattern just says that we've got some skeleton of algorithm, and then certain steps are deferred to subclasses. And we can see that that occurs here with deferring apply filter to the null filter and grayscale filter classes, which is defined abstractly in filter. Now, if we look at the grayscale filter and null filter classes, you can see that they are concrete components in the context of decorator, and they're also concrete classes in the context of template method. So again, high pattern density for those classes. And the key method here is apply filters we were talking about. So that's defined. And of course, the null filter doesn't do anything in its apply filter. It's a no-op, but the grayscale filter applies the grayscale algorithm. And we'll take a look at that when we look at the code here momentarily. Filter decorator is also part of the decorator pattern. It's the decorator portion of the decorator pattern, and it's got a method called decorate. And you can see it also plays the role of an abstract class in the template method pattern because of the way it's used in conjunction with other classes that are part of the task gang framework. And you can see all these patterns are described here at these links. And then the final piece of the puzzle here is output filter decorator, which is a concrete decorator. That's the role it plays in the decorator pattern. So that's quite a lot of mouthful. The output filter decorator is also a concrete class in the template method pattern, once again showing high pattern density. So that's an awful lot of stuff to remember from a design point of view. So now let's go ahead and take a look at the code, which is actually the ground truth in all this stuff. And this occurs in the filters package in the image task gang folder in my live lessons GitHub repository. So here we are back in the image task gang project in my live lessons repository. Let's take a look at the filters package. Here are the classes that we're interested in, and we'll start with filter. So this is that abstract class that defines an interface for applying filtering operations onto an image. And you'll see that this plays the role of the abstract class in the template method pattern and the role of the component in the decorator pattern. And here we've got ourselves a string name, which is the name of the filter. You'll see how that gets used. The filter constructor will basically use the name of the class without the package prefix as the name of the filter. So for example, it would be something like null filter or grayscale filter and so on. We have some constructor that sets the filter with whatever name we give it. We have the hook method, which is abstract, which must be overridden by a subclass called apply filter. Can be a no-op, as we'll see in the case of null filter. And then we've got the filter method, which calls the apply filter method. So this is a template method, which calls apply filter, and then it takes the filtered results, and it goes ahead and sets the filter name, and returns the filtered result, which is the image that's been filtered. And you can see here we have setter and getter methods to set the name of the filter and get the name of the filter respectively. So let's take a quick look at the sort of the no-brainer version of this, which is the null filter. And you can see this plays the role of the concrete component in the decorator pattern and the concrete class and the template method pattern. Null filter extends filter, and its apply filter method is a no-op. It just returns the image, nothing else to be done there. Let's look at something more interesting, which is grayscale filter. And you can see here that grayscale filter actually converts an image to grayscale, as you might expect. It also extends filter. It's got a constructor that will call up to the superclass to set the name properly. And then its apply filter actually does something useful. It goes ahead and applies the grayscale conversion using a so-called pixel by pixel coloring algorithm, or removal of coloring algorithm is probably a better term. And it does this by making a buffered image, and then it will provide this transform, and it goes through a loop through all the pixels. And you can read about how this works at this Wikipedia link, and basically converts it and converts the pixel, which could be color, could be a colored pixel, into a grayscale pixel. And then it updates things appropriately using this formula. And then it sets that to be the next updated value in the image. And when we're all done, we take the image that is the grayscale image, we make a new image. You can see image is just this kind of holder class that's going to keep track of the image and the source that it came from, if it's a URL, and then the name and whether the operation succeeded or failed, and so on and so forth, and just kind of associate all those things together. There's also a method we'll see later when we look at store that's used to store an image, and we'll come back to that when we get to that part of the walkthrough. Okay, so that's basically grayscale filter. Let's now go ahead and take a look at the filter decorator. So this is the decorator, and it also extends filter, but it's also going to associate it with the decorator. And so this plays the role of the decorator in the decorator pattern and the role of the abstract class in the template method pattern. And honestly, it probably should have been called the abstract decorator in the decorator pattern to be consistent with abstract class in the template method pattern. But be that as it may, the Gang of Four called it decorator. So the filter decorator keeps track of the filter to apply, and that gets set here in the filter decorator. And it's got an abstract method that must be filled in by subclasses called decorate. And it takes in an image, and it's going to apply the filter to it, and it'll then return the decorated or filtered image. And you can see its apply filter method, which it got because it's inheriting from filter, is going to call the decorate method, which is also abstract, by the way, in order to filter that image. So it's going to apply the filter on the image via the decorate method. So we're going to see how that works in a second. So here is the file decorator with image, and we'll see what that does in a second. This is going to be used to be a command object. And you can see when its run hook method is called, it's going to take the file decorator that was created here and the image, and it's going to apply the image on the filter using the filter decorator. So let's take a look at an example of a filter decorator. So this is a concrete decorator in the context of the decorator pattern, and it's called output filter decorator. And as the name suggests, it's going to go ahead and apply the filter, and then it's going to go ahead and have the decorate hook method write the result of the filtered image to the designated output file, which is based on the name of the filter. So you can see its constructor just takes a filter, and it's got a decorate method, which takes an image. And what it does is it goes ahead and it creates a new file just to make sure that we've got one that we need. And it'll then get a reference to the file that the image is going to be stored into. And we use these names here as appropriate to get what we need. And then we're going to go ahead and create ourselves a new file output stream. We're going to get the image, and then we're going to go ahead and write the image. So notice that the decorate method, when it's called, is going to cause the filtered image to be written to a file. And so that's what the output filter decorator does. And you can see over here, we have the filter decorator with image, which takes the filter decorator and the image and then applies the filter to it, which also causes it to store it. So that's a lot of stuff. And what's cool about it is that now it's all very extensible and we can add other filters without breaking anything. We could add different ways of doing output without breaking anything because we've used these patterns together to provide a high density pattern design.